Okay, in this lecture, we are going to learn the electromagnetic waves. So, in communication, there are like 2 points important. That is a space communication and line communication. Okay, so as we have to know that the space communication is like a non-directional form of communication. So that one by we can freely transmit a signal in space using transmitter antenna and can be received by intercepting the signal with the help of receiver antenna. And in line communication, we can communicate by using a physical path like cables or fibers. Okay, so that you have to remember first. And here more important is also Earth's atmosphere, that is ionosphere, tropospheres and all that. So before we move that, we have to know what is electromagnetic waves. This, if you can see here, this is the electromagnetic waves. Okay, when the Earth is created, let's say when the Earth is created, that time the charged particle is already present in the earth. Okay, so not on the earth, in outer space like universe. When the sun is set or not, no, there is no sun. Okay, there when the sun is there, or once you get the radiation, that time the charged particle is moving. The charged particle is moving. The charged particle is the electric field. So if you look at here, this blue color is the electric field. So that charged particle is moving, oscillate, that or moving or oscillate, that motion is moving. So once that moves, it creates electromagnetic field. So this concept can be explained by using Ampere's law. In Ampere's law, in kut khatihan hum taula kuzung pi khatunga da chau taula. So if you hold your hand and if you put your finger upper side, so that your thumb will represent the electric field, and the other four fingers, if you hold, the other four fingers represent the magnetic field. Okay, kaka akal tantuni. That means this electric field and magnetic fields are perpendicular to each other. Okay, Chuan ani Chuan, that motion doesn't stop. It keeps on going. It keeps on going. Once it get the radiations or photons, so we got electromagnetic waves as photons or again, let's take until photons there. Radiation te po kan tiang kha o chon khang aron move to electric particle kan ti ho te khan electric field aron siama. So electric field kha ron cham motion aron siam tar char ta ni chu speed of light kan ti te po kha ni ta kha motion ron char char kha ni magnetic field kha ron siam ta chuan heng ho pani te hi enge perpendicular to each other ani thung ta ni chu chuan ni ka se dong khan atop lawa ron char ron ka radiation ron pass char ni chu propagating kan ti ho kha yang o. So electromagnetic waves are also known as EM waves that are produced when an electric field comes in contact with the magnetic field. It can also be said that electromagnetic waves are the composition of oscillating electric and magnetic fields, and electromagnetic waves are solutions of Maxwell's equations, which are the fundamental equations of electrodynamics. So these two perpendicular to each other, electric field, and or you can say the relationship between electric field and magnetic field can be explained by solution for Maxwell's equations. So Maxwell's equations, so four equations and so we have already explained here how electromagnetic waves form. Electric field is produced by charged particles. Okay, once you get a radiation, remember once ang pokvel charged particle doni, that electric field is produced by a charged particle. A force is exerted by this electric field on other charged particles. Okay, so positive charge accelerate in the direction of the field, and negative charge in the direction opposite to the direction of the field. Okay, magnetic field produced by moving charged particles. Magnetic field produced by moving charged particle or electric field. Electric field magnetic field a force is exerted by those electric field on other moving particles. The force on this charge is always perpendicular to the direction of their velocity, and therefore only changes the direction of the velocity, not the speed. Direction of velocity chau khat lak dang lang speed ni lovin. So atyang turangayang. So the electromagnetic field is produced by an accelerating charged particle. Electromagnetic waves are nothing but electric and magnetic fields traveling to free space with the speed of light, or with the speed of light. So in till communication current imbek po nakala ni chong lo moving charged particle may kala ni oh. So an accelerating charged particle is when the charged particle oscillates about an equilibrium position. So here we got the wavelength. Now by using this the electromagnetic, or by using these electromagnetic waves transferred energy through space. Okay, so this is the wavelength. C is the velocity, the speed of light, and F is the frequency. So the properties tunjagan so ito kan electromagnetic waves travels at the speed of light and do not require any medium for propagation ang mamamulaw inom to sa radiation ng kalto sa narong katlang tupang electromagnetic waves traveling in transverse form. Transverse form means electric field and magnetic field are perpendicular to each other. Electromagnetic waves are not reflected by electric or magnetic field. These waves can be polarized and it's one unidirectional. So kan direction katso ni don tinani electromagnetic waves undergo interference and diffraction. So electromagnetic waves ha chuan ka soi thei chin ni phut se Maxwell equations te po kha thra chen ngai don tinani ya ma se thil har sa ni chong lawa it's perpendicular to each other, and based on these properties, you can explain about the electromagnetic waves and propagation ni dante po ka o ini to chang ka tlang cha rang ka ti kha. So here the next topic is propagation of waves. Propagation of waves, ground wave, space wave, and sky wave. Elementary concepts about propagation of waves ka tutuna mi kha ka dutok thei nga chuan by using Ampere's law the pogati the Maxwell equations the solution ani kan ti kha. So propagation of ground wave, space wave, and sky wave ti om leta. So before we move on to the next topic here, we need to know what the Earth's atmosphere. Okay, so Earth is surrounded by a gases called atmosphere. Earth ka atmosphere in I cover ka so kan sha to ni so turo chuan enge khami composition kha khuya pokhen angvek chong lawa chuan ma se the atmosphere, this atmosphere plays an important role in the transmission of electromagnetic waves. Okay, chuan and the Earth's atmosphere is divided into different layers. First is troposphere. Troposphere to engting e ka sha ton troposphere ni chuan surface Earth tanga up to 12 kilometer te po wan tianga kha chu muntanga danga ma se danglam emelo pani khat kilometer ni khat lek ken danga nga chuan, and here the troposphere chu atnoi ber ani the lowest atmosphere, the lowest layer is the height of 12 kilometer from the surface of the Earth, and this layer mostly contains water vapor which leads to the formation of clouds. And lauvel chungbe kan mulo siam tu khani chuan khami izir kha kan troposphere layer zir khanin I kan leya kan atmosphere kha danglam thim berani o heta hi chuan stratosphere omlia chu the reason of this stratosphere lying between 12 kilometer to 50 kilometer, and here the ozone layer is part of that stratosphere from 15 kilometer to 30 kilometer and this one absorbs the harmful UV rays from the sun because we know that UV rays are very harmful to living cells. Okay, so next is mesosphere. The reason of mesosphere lying between 50 kilometer to 80 kilometer hi a kilometer chin te hi ke man ka ziak lo ka karon chiar lo ka ni o he mi bi ka hi chuan chu heta hi chuanin 50 kilometer 12 kilometer length troposphere anita so stratosphere to 12 kilometer to 50 kilometer anita mesosphere to 50 to 80 te khanita so ionosphere bethung to 80 to 400 kilometer chinangka outermost layer kan te khanita so the ionosphere, this ionosphere contains charged particles and play a very important role in space communication. Okay, so kachu enge ka UV rays express well kanti va kachu kan she do nal to rangai taila chuan radio waves ate popoi moja kan she a chuan lo next ha chuan ground wave communication akal taila tuna kan se jong jong kha khang ho jong jong khanin electromagnetic waves akan earth atmosphere kha important role kha play to a chon he ta hian next topic an ionospheric layers te ma ta hian tlem te kha nge englo zokin ti karon to manga details developing. So ground wave is a type of radio propagation here. This one also known as a surface waves. And these waves propagate over the Earth's surface in low and medium frequencies here. So heta hi chuan an frequency here below 1500 kilohertz din chin ta. So and these are mainly used for transmission between the surface of the Earth and the ionosphere. Okay, mainly used for transmission between the surface of the Earth and the ionosphere. And these are made up of the number of constituent waves. So electromagnetic waves are emitted from the transmitting antenna, propagate along the surface of the Earth. Okay, surface of the Earth, and the type of this propagation can take place when the transmitting and receiving antenna are close to the surface of the Earth. Okay, so ground of a propagate surface and lautung ang ground of a propagation heta han thil pui mudo pakhat oma edit current sa here and in siam chin ta chu chuan in edit current sa te khan in wave sa te kharon attenuate aron te doi don te na ni so when a ground of propagations over surface of the Earth here edit currents are induced in the surface of the Earth, which causes attenuation of those waves. Okay, so they travel over the Earth's surface. They bend along the curvature of the Earth, which results in energy losses. Okay, and each one, thus ground wave propagation is restricted to small distance. Restricted to small distance. Mase a maximum range sa khachu transmitted power te frequencies yote khana le don ti na ni ta he tanga ve thung hi chuan ma se dang ho chu high frequency te enge FM kan manang che broadcast a khan til tukin a man rim chang ve vak lawa chuan ground wave a transmission na de kha antenna atak tok lo thina kha tenga khan electromagnetic waves atekha antenna electromagnetic waves of frequency te increase to khan khatenga khan ground wave atekha chakjok lo thina and this type of transmission is restricted to frequencies below 1500 kilohertz. Okay, and here hetapo hian kan punga number of constituency curvature of the Earth, enabling them to cover beyond the horizon. Beyond the horizon, the waves get blocked by the curvature of the Earth and the signals produced by the diffracted surface area. So the advantage here, and these are the advantages. These waves have the tendency to bend around the corners of obstructions during propagation, which makes them more efficient, and also these are not affected by the change in atmospheric conditions. We have already explained that. And disadvantage too, high frequency waves cannot transmit it as the energy losses are more because of the absorption of energy in the Earth's atmosphere. This main reason is eddy current loss. Okay, and these are used to cover short ranges and also involve attenuation of waves as they interact with the eddy currents produced by the surface of the Earth. We have already explained that. And these are used in AM, FM, and TV broadcasting can be done with the help of ground waves and can be used for one-way communication from the military to submarines as they penetrate to a significant depth into seawater. Okay, so next is here sky wave. Tihemi vetung hitu electromagnetic waves. The electromagnetic waves emitted by transmitting antenna are received. A transmitting antenna are received after reflecting from ionosphere. After reflecting from ionosphere, a sky wave vetung to the electromagnetic waves. Here, sky wave the electromagnetic waves emitted by transmitting antenna are received after being reflected from the ionosphere, and these types of waves are sky waves. Okay, and sky wave and propagation sky wave propagation so here this one sky wave propagation occurs due to the due to the internal reflection of the electromagnetic waves by the ionosphere. And here the ionosphere te khan free positive and negative ions te kha aron produce nga chumi chu ionization of atoms and molecules present in the atmosphere ni do thung don ti ta ni heta atmosphere atoms and molecules from present the khan in free positive and negative ions te kha ron siam don ta chuan the charge density of the ionosphere increases with height, which results in decrease in its refractive index. Ve thung do ni chon heta hianin claim en lawaron tel ve thonga chuan here the electromagnetic waves are having frequencies less than 2 megahertz and that are absorbed by the ionosphere and having frequencies greater than 30 megahertz ve thung ka chu apas ve thung don ti na ni 2 megahertz ai ni ma ka chu absorb do na ma se 30 megahertz ai sang hawa kha chu alo enge at pass ve thung don ti na ni chu ani chuan, or we can say that the waves with the frequency range from the sky wave with the frequency range from 2 megahertz to 30 megahertz can be propagated by using this sky wave propagation. Okay, so these are the frequency DEF1 ti omang nakin ionospherically aro omanga ta chon DEF1 how to engwin sa mingen di kha chang to nga chuan hetai maximum usable frequency DME te E layer te F1 layer mi te no le tunga optimum working frequency om le nga chu depending upon the layers of the other ti he chumi chu undistribute ani D layer E layer F1 layer vela unron distribute dan ti na ni o heta ve thung hi chuan hetai ham thilpui mo oma critical frequency ti te om bele thung ta chu critical frequency to maximum frequency which total internal reflection from ionospheric takes place, or critical frequency to total internal reflection na diya nga to ionosphere o maka total internal reflection na kani thungani. Critical frequency is defined as the maximum frequency at which total internal takes place from the atmosphere. Mathematical representation na oma FC2 critical frequency ni nga Nmax sahitu maximum electron density per m3 or maximum electron density of the ionosphere, we can say maximum electron density of the ionosphere here. So this is the formula for the critical frequency, and mathematical representation frequency as a function of maximum usable frequency to sec theta. Critical frequency has maximum usable frequency angular incidence to 1, and critical frequency varies depending upon the atmospheric conditions, time of the day, and angle of radio waves by antenna. To one, skip distance skip distance to minimum distance from the earth's surface and the point from where the radio signal is being transmitted to. For a flat earth, skip distance to hey formula ni vela thunga nga skip zone to silent zone or zone of silence where radio transmission cannot be received. Radio transmission don't tell na ka skip zone diyan iton critical frequency te skip distance skip zone ti omton is and the zone is located between regions both closer and farther from the transmitter where reception is possible. And these are the applications: mobile communications and satellite communications with the help of sky waves, as it is dependent on the para atmosphere conditions. Ionospheric layer consider ngatiang le ngayang. So space wave betung hitu radio waves that occur within the 20 kilometer of the atmosphere, that is troposphere, comprising of a direct and reflected waves. And here the electromagnetic waves emitted by transmitter antenna travel directly from the transmitting antenna to the receiving antenna. The electromagnetic waves emitted by transmitter antenna travel directly from the transmitting antenna to the receiving antenna within the 20 kilometer of the atmosphere. So it is used for line of sight communication and satellite communication. As you know that high frequency electromagnetic waves cannot be transmitted as ground waves due to high energy loss, but we know that these waves are absorbed by the atmosphere and hence they cannot be transmitted via skywave propagation. So such high frequency electromagnetic waves are directly transmitted to Earth's atmosphere using a transmitting antenna, as those are traveling in a straight line. The receiving antenna must be in the line of sight the transmitting antenna. Okay. So here direct and reflected waves, these waves are also known as tropospheric propagation, as they can travel directly from the Earth's surface to the troposphere surface of the Earth. Line of sight propagation signals in a straight line from the transmitter to the receiver. Okay. Thil har sa EM2 ning kashel lem hei lawa. So in order to prevent attenuation loss of signal strength, the height of antenna and distance between them can be given as these are the formula dm2rht to the power of 1 minus 1 by 2 plus 2rhr. Dm is distance between the two antennas, r capital R radius of the r, ht is one height of transmission antenna, is also height of the receiver antenna. So applications are line of sight communication, satellite communication, weather communication, so it's all ngai lawanga. So headline limitations on tani. These waves are affected by the curvature of the earth. The propagation of these waves happens along the line of sight, which can depend on range of communication. Transmitting range for an antenna of height 100 meters. Transmitting range at tani. If a transmit na tura azaw zong tina ni meta. Antenna height 100 meters appear. This antenna height can be antenna height of transmitting antenna le receiving antenna height ani me nga transmitting range ati ve thong radius of art you can look for the radius of art from Google. Here you will find the radius of art and transmitting height of antenna le receiving height of antenna ta kamne anga. You can find the distance between the two antennas, or you can find the transmitting range. So try to find out the answer for this one. And lauchianon le ula adang lam na te hentang wave propagation how dang lam na te a concept electromagnetic waves at here. Propagation minozo tanga. So the next topic is ionospheric layer. So if you still have any problem with the ionospheric regarding this ionospheric, so we will try to clear up in the next class. Okay.